Hallo und herzlich willkommen zur
Hello
Vector
and
Virtual Week.
welcome
Mein
to
Name
the
ist Eduard
Vector
Metzger.
Virtual Week.
Ich
I'm
präsentiere
Eduard
Ihnen
Metzger, and in
im
my
Vortrag,
presentation I will
vor uns liegt
present
ein
a
Thema aus dem
topic
Bereich
from
Cybersecurity.
cybersecurity.
Und genauer geht es
In
darum,
detail,
die
it's about the
Standardisierung
standardization
von
of
Intrusion
intrusion
Detection
detection
Systems
systems
für
for
das
the vehicle.
Fahrzeug. Dann gebe ich zuerst mal einen
First of all, I will give you an
Überblick über
overview of
die
the
Agenda zu
agenda
dem Vortrag.
of my presentation.
Ich beginne mit einer Einleitung zum Thema
I will start with an
Intrusion
introduction
Detection
on intrusion detection
Gehe auf
systems.
einige der
Then I will
Begriffe
talk
ein,
about
die für
some
das
important
Verständnis des
terms which are
Grundkonzepts
necessary
wichtig
to
sind
understand the overall
und
concept.
anschließend auf praktisch den Bereich
And
der
then I will talk
Standardisierung,
about the
das heißt,
scope of
welchen Ausschnitt aus dem
standardization.
Thema Intrusion
This means
Detection Systeme,
which
welcher Ausschnitt
scope
wird
we
von
have
AUTOSAR
within the intrusion
standardisiert.
detection systems and which
Dann
part
schauen
of
wir
this
uns
is
etwas
standardized
genauer
in
an
AUTOSAR.
die Softwarearchitektur, die
Next,
dahinter
we'll
liegt,
have a look at the
eine
software architecture and the protocol.
Und ein ganz wichtiger Punkt sind noch
And
die
another important point are the
Security
security
Events
events which are also standardized within AUTOSAR.
auch einige beispielhafte
And I will
Events
present some exemplary events.
Abschließend möchte ich dann mit der
I will
Vorstellung
then
des aktuellen
conclude
Status der
by
Standardisierung,
presenting the
Weiterentwicklungsprozess
status quo
an, es mit Ergebnissen
and
zu
tell you how far we have gotten in the process, and then I will close with a summary.
Gut, das Big Picture zum Thema
Now, the
Intrusion
big picture on
ist im Prinzip
intrusion detection system.
Ziel,
The goal is to
Incidents, das heißt
detect security
Vorfälle
incidents
möglichst
at an
früh
early
und schnell erkennen
stage
zu können
and
dann auch in der
then
Lage zu
being
sein,
able to take
Maßnahmen
measures
einzuleiten, solche Security-Vorfälle
to
ihrer
alleviate
Auswirkungen
the
abzumildern,
impact
zu begrenzen
of
und
these
auch vielleicht
incidents,
für
to keep
andere
them at bay,
Fahrzeuge
and also to prevent them in
verhindern.
other vehicles.
Die Grundidee ist dabei, dass wenn ein Cybersecurity
Now,
ein
what we
Fahrzeug
aim at is that a
stattfindet,
cyber
dieser
attack
Angriff
leaves traces in the vehicle architecture in the form of security events.
Das heißt, es gibt
This means
Sensoren
within the
im
vehicle
Fahrzeug,
we
die
have
solche
sensors that
Security-Ereignisse
detect these
detektieren
incidents,
und
and
mit
by
Hilfe
means
eines
of an onboard intrusion detection
Systems
system,
werden
these events are then logged
aufgezeichnet, damit
so
sie
that they can
später
be
auch
evaluated later on.
Zusätzlich zu dieser
Additionally to
Onboard-Speicherung
saving
von
these onboard
Security-Events
data,
gehört zum
the
Gesamtkonzept
overall
auch,
concept also
dazu,
includes
dass
that security events are
an
reported
ein
to a
Backend
backend.
reportet werden können.
This
Das
is a
ist ein
so-called
sogenanntes
security operation
Center,
center.
das entweder von
It can be
Herstellern
operated
betrieben werden
either
kann
by
oder auch
manufacturers
von
or service
Service-Providern.
providers.
Und dorthin werden dann Security-Events
Security events which have been detected in the vehicle are reported to the
zu einer
SOC.
Gesamtsicht
They are
der
then
Flotte
integrated into
integriert
an
und
overview of
die
the fleet,
Experten
and the
oder Analysten im
experts
Backend können dann
at the
letztendlich
backend can
feststellen,
realize what
was
the
die
root
Root
cause
Cause
of
der
the
aufgezeichneten
logged
Events
events is.
Das
It
muss
doesn't
nicht immer
always have to be a
Security-Problem
security
sein,
problem,
aber
but if it is a
falls es ein
security
Security-Problem
problem,
ist, können auf Basis dieser Analysen
countermeasures
dann
can
auch
be developed on the basis of this
werden,
analysis, for example, new software versions. And
die dann
after
nach
elaborate
ausführlichem
testing,
Test auch
they
direkt
can be deployed
auf
to the
Fahrzeuge
vehicles, for
zurückgespielt werden
example,
können, zum
via
Beispiel
software updates
Software-Updates
over the air.
mit dem Ziel, dass
And the
diese
goal is that the
Updates
updates
dann
make
dafür
sure
sorgen, dass
that
der Flotte
the
möglichst
remaining fleet is
diesen
immune against the
bekannten
cyber
wird
attack,
und so
and this
zukünftige
way
Schäden
it can
abgemildert werden.
hamper future damages.
Was zusätzlich für Interesse
What
gesorgt
has also
hat an
caused
solch einer Gesamtlösung
a
sind
buzz
auch neue
are new
Standardisierungsoffensiven
standardizations within
im Bereich der
the
Prozesse.
processes.
Also
For example, the ISO 21434 requires a security incident and response management, and the UNECE also requires that vehicles are to be able to log security events so that they can be analyzed later on. So these are two more trends from the standardization of processes and legal requirements which make sure that the interest of these intrusion detection systems are on the rise. Within the scope of AUTOSAR standardization, it is currently focusing on the handling within the vehicle. This means the emphasis of standardization targets the question how security events can be detected and how these security events can be logged, and how the data can be prepared so they can be sent to the backend. Basically, you can imagine that the vehicle, with all its control units, is a distributed system. In case of a cyber attack against the vehicle, it might be necessary that the attackers have to get over several security hurdles. This means that the attackers need to have access to the vehicle. Then they have to gain control over one of the control units. They might have to bridge specific domains to actually get to the target domain which they want to manipulate, to then manipulate the control unit or to send out messages or to evoke the desired failures. Since the security attacks don't only happen at one central point in the system, it is not enough to embed an intrusion detection system, so a system that logs and processes security events can also not only be at one central unit in the architecture. Therefore, a distributed onboard intrusion detection system is specified in AUTOSAR. And if necessary, its components can be spread over the entire software architecture. If we have a closer look, the distributed onboard IDS architecture consists of security sensors. These are any software components which can detect and report security incidents. This could be, for example, manipulated messages which have been detected. It could be that it detects it via a diagnostic interface where the authentication failed. But for instance, it could also be that a certificate could not be verified. This is to say that we deal with an enormous range of security events. And depending on which tasks the control unit needs to fulfill and how much of the core software is implemented. And of course, it can also depend on the applications running on the control unit. This means the security sensors pass on the information of security events to a central software component on every control unit. Within the scope of AUTOSAR, it is called Intrusion Detection System Manager, IDSM. The IDSM has the task to receive and to buffer these security events and to process them, particularly to filter them. Thus, it is pre-processing the data to reduce the data volume to a manageable proportion. And in the first step, it can already eliminate false messages. And every control unit processes the data individually and locally, and the security events can be stored permanently there. Furthermore, it is also possible to configure the whole system in a way that the security events don't remain locally stored on the control units where they were detected, but the information on security intrusion events can also be looped through to an intrusion detection system reporter. And this is a software component which is running on a control unit, which typically is connected to a backend. All security events that were detected in the vehicle converge here. Here, the data can also be enriched, for example, by timestamps or by geodata, before they are then transmitted to the backend for analysis. Now, before we have a look at the architecture, I would like to talk about a few terms which reappear within this concept. As I mentioned, security event sensors, that is a term for any software components which report security events. The IDSM, that is the position where the security events are received and processed. And after processing, after this step of filtering, the security events are so-called qualified security events. And for these qualified security events, it can now be decided whether they will be stored locally in the diagnostic memory, in the security event memory, or whether they are transmitted to the IDSR to be sent to the backend. And for this processing step that the IDSM is doing in security events, we have coined the term of filter chains. A filter chain is a sequence of filter elements through which the reported security events are routed. Only security events that have passed every one of these filter elements will then become qualified security events. In AUTOSAR, a number of filter elements have been standardized. I will not talk about these in detail now because we are running out of time. However, based on the combination and the setting of parameters in these filter chains, any desired filtering can be implemented. This way, all requirements can be met. The goals of standardization in AUTOSAR are to specify, first of all, to specify the interfaces for reporting onboard security events so that they are uniform for all the software components in the core software and in the applications. Secondly, the qualification filters I just mentioned are standardized. These have the task to transform them into qualified onboard security events. And thirdly, an important subject is that the protocol is standardized. It describes how security events can be transferred from the local IDSMs to the IDSRs. This way we get a standardized protocol which works across different bus systems. The fourth point is also important. AUTOSAR also specifies which security events are reported by the core software itself, and this has the advantage that we avoid uncontrolled growth of data, of security events, if they are given by the modules of the core software. And the first candidates of modules is the key management module, the diagnostic communication management, secure onboard communication, and TLS. Presumably, these will be the first modules which contain standardized security. Now, on the IDS software architecture, the module is in the crypto service layer on the same level as the available modules Key Manager and CSM. This is just because they are interfaces to the application level and to other core software modules. On this image, you can see the architecture and the interfaces of the IDSM within the scope of the AUTOSAR classic architecture. Marked with blue arrows, you see exemplary so-called security sensor modules. One example is the DCM module, SecOC, and the KeyM module, and also an application. In this example, these would transfer security events to the IDSM. The IDSM would process these security events on basis of the filters and then pass them on for permanent storage to the DM. And if required, The security events which are locally stored can also be safeguarded with the crypto service manager, for example, by encrypting the data or by verifying whether the security events have been manipulated, for example, with a message authentication code. And then, aside from the local storage of data, the security events can also be sent to the IDSR, and for this, the IdsM has a connection to the PDU router by AUTOSAR. At the same time, it is also standardized for the AUTOSAR adaptive platform, and in terms of the technology, it looks a bit different. In this case, there is a library, and through the application of platform modules and OS, it can be included. And this gives us the opportunity to report to the IDSM daemon. And via the bus, it can transfer the security events to the IDS reporter. As I mentioned earlier on, it is now important that we are standardizing a protocol where we can get security events, for example, here of this node A can be sent via the router, and then regular gateway mechanisms loops it through, and then via an Ethernet connection it gets to an adaptive control unit where the IDSR is running and where the IDSR receives the sent security events. To facilitate the work with this concept, AUTOSAR will define a number of standard security events. Here you see a collection of these security events on a table, and every line of this table shows one security event. And for every security event, we wrote down to which asset it refers to. This could be crypto material, it could be communication, or it could be the OS itself. Next, we see which possible threat to this asset is possible and which security event is available, which can be reported in case of such a threat. We expect that this is a first coverage with the AUTOSAR standard 2011 that is coming up, and a large number of security events could be covered already through the AUTOSAR standardization. Now, on the status of standardization, as of middle of April 2020, the concept has passed the milestone 2. This means we have gone through the first phase of elaboration and are currently now in the second phase of detailing of the AUTOSAR concept. Approximately in November, we will release the concept in AUTOSAR. And from then on, the Intrusion Detection System Manager will be a regular feature of AUTOSAR. And if you are a member yourself, you can use this data, for example, the concept name and the ID number, and you will have access to this concept. The concept owner is me, Eduard Metzger by Vector Informatik. And if you want to have the status quo, and if you want to know what is happening, please feel free to get in touch with me. And apart from working on standardization, Vector also advances the product development. We have been very early in developing of the IDSM for the classic platform. This is to say, we are even a bit ahead of the standardization. This July, we will already deliver a first beta version to our pilot customers, and a second beta that is to be feature complete will be delivered in November, and then we expect a production-ready status in the first quarter of 2021. And if you would like to be in this pilot program, just get in touch with Vector. Now for the components of the adaptive platform, they are still in the process of planning, but we plan to get the IDSM and the IDSR ready for the adaptive platform. Now, as a summary, I would like to share some of the feedback from our customers on the advantages of this standardization. The standard offers a technical framework for the implementing onboard IDS systems, and this is not only made for the adaptive platform, also for the classic platform, and this is to guarantee the cooperation between these two. It allows a distributed approach which prevents a single point of failure. And because of the versatile configuration options, for example, the local storage or transmitting security events to the backend, helps us to use the available resources, and we can balance them with the needs to develop an effective IDS system. And with this number of different configuration options, it is also possible for us to meet the different needs of OEMs and vehicle EE architectures. Another great benefit that the first customers have already confirmed is that AUTOSAR itself already brings along some standard security types. For example, everything that a CAN driver can do, or an Ethernet driver can do, will be available already as a security event within AUTOSAR with the new stacks. But then, of course, you can also specify your own security events. The feedback from the security community of startups and specialized companies is that they have the opportunity now to implement their own innovative security sensors, and that they can also contribute their own know-how in terms of the definition of the qualification rules. And this way, the requirements from the process standardizations of the automotive industry, is faced with can serve to be a state-of-the-art. And it can be a reference concept for an onboard IDS, where you can align your own development to. Another benefit is that this standard is continuously developed and maintenance is done by AUTOSAR. And that we can clarify many technical details within the scope of standardization, which no longer have to be coordinated between the OEMs and the suppliers. From our point of view, this is also a great cost-cutting opportunity to realize an intrusion detection system. Now, on that note, I would like to end my presentation, and I hope it included useful information for you to take home.